Okay, video lesson 5.4 for the note-taking guide. I'll go through the vocabulary first, and then we'll talk about the theorems and what they mean. So the legs are just the two congruent sides of an isosceles triangle. Remember our isosceles triangle, so that would be the two legs, so the two congruent sides of an isosceles triangle. The vertex angle is actually the angle that is in between. So it is the angle formed by the legs of the isosceles triangle. Oops, I just wanted to make that a little bit bigger. Okay, so the base is the third side, so the remaining side on the isosceles triangle. And it is the side across from the vertex angle. Okay, and then the base angles are the two angles that are adjacent to the base on the isosceles triangle. So if this was my isosceles triangle and those two sides were the legs, the base angles would be the two angles across from those. So the two angles across from the legs. Okay, we have two theorems that we're going to discuss. We're going to discuss the base angle theorem, which says if two sides of a triangle are congruent, then the angles opposite them are congruent. So in this example, if AB is congruent to AC, then right away you know that angle B is congruent to angle C. So if you start with sides, you have congruent angles. Okay, and then the converse says if two angles of a triangle are congruent, then the sides opposite them are congruent. So that means if you start with the angles, then you can make the sides congruent. So pretty much base angles, you start with sides that are congruent and you make the base angles congruent. And the second theorem, you start with angles being congruent and you make base angles congruent and you make the sides congruent. So the initial one, base angle, starts with sides and makes angles congruent. The converse starts with angles and makes sides congruent. So there's a corollary again. Remember, a corollary is nothing more than an add-on. So there are two corollaries to the base angle theorem and the converse of the base angle. So pretty much if a triangle is equilateral, then it is equiangular. Remember, equilateral and equiangular. So equilateral is all sides are congruent and equiangular is all angles are congruent. So if it is equilateral, it is automatically equiangular, and then they switch it around. If it is equiangular, then it is equilateral. So if a triangle has all three angles the same, then it means all three sides are the same. And then don't forget, by definition, on an equilateral, equiangular triangle, then all of the angles are equal to 60. So 60, 60, and 60, which we found by doing the triangle sum theorem of 180 divided by 3. Okay, if we look at the extra practice, we're looking at this picture, and I think I'm just going to erase each time. Let me grab a pencil and eraser. Okay, so for instance, if we look at our picture, it says if side NJ is congruent to side NM. So here's side NJ, here's side NM, and they want to know which angles are congruent. So it's the outermost angles So the two angles that are across from those sides, so this angle M is across from side JN, angle J is across from side MN. So in this case, angle J is going to be congruent to angle M. Okay, if we take those marks off, then we take a look at, we now have two different sides. So with LM, so here's LM and LN. Okay, again, we have two sides, so that means we have to look to the angles opposite them. So this side is across from this angle, this side is across from that angle, so that means angle M is going to be congruent to angle LNM. So this can be angle M, or it could be angle LMN. Because don't forget, you can use three letters, or if there's no other angles attached, you can use the plain letter M. But in this case, this one here, L and M, we have to go with three letters so that we know which part of this is the angle that we're referring to. So we're going to say L and M, and again, that could be angle it was angle L and M, or it could be angle M and L, but L has to be in the middle because that's the vertex. Okay, then we're going to erase, start over for number 3. So now we have angle NKM. So NK to M. So there's angle NK to M. And then we're going to look at NMK. So NMK. So now we're over there. So if these two angles are congruent, that means by the converse that the sides across from them are congruent. So that means this side is going to be congruent to that side. So we have NK is going to be congruent to NM, and again, this could read KN or MN. Okay, so if we do it one more time, we have two more angles. So angle LJN, so LJN, so that would be this angle here, is congruent to LNJ, so LNJ, so that would be this angle, this whole angle here. And again, if we look to the sides across, then we're looking to the side of JL, which is this entire side here, because we're looking at this triangle here, and then this angle across the side across from angle J is going to be LN. And again, that could be LJ or NL. So, extra practice, you're just using the base angle theorem or the converse of the base angle theorem. So if you start with sides, you find angles that are congruent. If you start with angles, you find sides that are congruent. Okay, so now we're just using some examples, or doing some examples that use the ideas of isosceles or equilateral triangles. So if you look at number 5, you have an equal angular triangle, because all three angles are congruent. So in the case of this, you would know that all the angles are 60 degrees. However, they're looking for just a side. So you also know if it's equal angular, it is equilateral. And remember, equilateral means all sides are congruent. So if we look at this, if 31 is on one side, the other side has to also be 31. So not too bad on that. Okay, if we look at number 6, now we're going to do the same. Now we have sides, so we're actually equilateral to begin with. So that means all of our sides are congruent. So we have a 12, a 12, and a 12. But then that also means, again, if it's equilateral, it's equal angular. So that means all of our angles are congruent. So I can make each of these a 60, which means that angle Z is also a 60. So to solve, 2x equals 60 or x equals 30. Okay, then they're going to put more than one picture together for you to try to work off of. So if you look at number 7, we have an equilateral triangle here because all the sides are the same. So if this side is y minus 25, that side is y minus 25, and that side is y minus 25. And if we look at this triangle, it is an isosceles triangle. So we need to find what the sides are and what the angles are based on this information. So the first thing that you have is, remember, if this is an equilateral triangle, that means all of the angles are 60. So that means if this is a 60-degree angle on this part of it and it's a 90-degree angle in its entirety, that means I can make that a 30-degree angle. Okay, once I fill in the 30-degree angle, I can now find my base angles, because I do 180 minus the 30 that I know as the vertex angle. I have 150 left. I cut that in half because remember, these have to be congruent base angles, so that means y is going to be 75, and of course the other angle is also going to be 75, so the base angles are 75, because now we have our triangle sum theorem. 75 plus 75 plus 30 makes 180. Okay, so our y was 75. Okay, then if we continue around, we remember we said each of the sides were y minus 25s. So in the case of solving the problem, this side was y minus 25. Remember, these two were base angles, they're congruent, which means these two sides also had to be congruent. So x had to be equal to y minus 25. We already know what y is, so x had to be 50. So in the case of number 7, x is 50 and y is 75. Okay, if you take a look at the last problem, number y, again, we have an isosceles triangle, which means we have a vertex angle of 40 degrees. So we do our 180, take away 40, we have 140. We cut that in half. That means each of our base angles had to be 70. So our x is 70. And then if we look at our other triangle, it's an equilateral triangle because all of the sides are the same. So that means that 2y plus 10 has to equal x minus y, and we just solved for x, so 2y plus 10 has to equal 70 minus y. So now we just have to rearrange all the variables to one side, all the numbers to the other. So I'm going to add a y, so 3y plus 10 is going to be 70, subtract my 10, 3y is going to be 60, or y is going to be 20. So these are examples of things that will be on your homework. That should take care of all the ideas in section 5.4.